Transportation is going electric, and many are excited about it. Although electric vehicles offer many advantages, they also present several challenges. The transition to electric vehicles may be a double-edged sword for the U.S. economy. Increased risks of cyberattacks and severe weather could characterize the U.S. vulnerability with an all-electric vehicle economy on the charging infrastructure, drivers, and utilities. If the U.S. power grid shuts down for any length of time, all electric vehicles would come to a standstill. Electric vehicles are part of the future. However, what isn't yet clear to some is the economic consequence of America going all electric on the roads. Read on to discover why electric cars everywhere may not be entirely rewarding for the economy, and what we need to do to prevent these problems. What is the problem with electric vehicles? Despite their many benefits, electric vehicles pose some risks to the U.S. economy. The problems with EVs are linked to how they work and the models that manufacturers could choose to build. Let's see how things could go wrong if every American driver got an electric vehicle. U.S. power grid problems could shut down electric vehicles. The U.S. power grid is the backbone to the all-electric vehicle economy. From domestic terror attacks, cyber attacks, age, or extreme weather, the U.S. power grid is vulnerable. Just like if you cannot get gasoline, you can't drive your car. If you can't charge your electric vehicle, you are not going anywhere. Weather-caused power grid outages have doubled over the past 2 decades across the U.S. Physical attacks on the power grid rose by 71% in 2022 compared to 2021. Ballistic damage, which means shooting a gun or a rifle at the power grid substations, is on the rise. As you can see, the U.S. power grid or sections of it could be shut down at any moment and is extremely vulnerable for many reasons. Power grid shutdowns can affect hundreds of thousands of people, if not more, for each occurrence. Cyberattacks on EV systems could cripple the U.S. economy. The shift to electric vehicles could pose a significant risk to U.S. cybersecurity. EVs not only run on electricity instead of fuel, but they're also part of the Internet of Things, a broad network of Internet-connected devices. The equipment that charges the EVs are connected to the Internet to enable communication. The EV charging infrastructure is connected to the U.S. electric power grid. As a result, there are multiple points hackers target cyberattacks on the grid which disable the EV systems. Electric vehicle charging stations collect customer data. EVs charging stations collect customer data that can be valuable to hackers. For example, stations can capture details about a car's charging rate, energy consumed, identification number, location, and the driver's payment information. There's already a considerably large market for consumer information, with many large companies and conglomerates coming under fire for their handling of personal data. As electric cars become commonplace, this problem could get even worse as information about you could be used to launch identity theft attacks. Hackers could use information exchanged at charging stations to launch denial-of-service attacks to lock drivers out of their cars. Cyberattacks on EVs charging networks could be catastrophic to the U.S. economy. For example, an attack on the U.S. electrical grid could not only paralyze transport and prevent millions of people from driving to work, but also disrupt emergency services. Securing EVs charging infrastructure against cyberattacks. As EVs adoption has risen, charging stations are increasingly being set up to meet the growing demand. With the charging network expanding, its vulnerability to hackers also increases. There is an incomplete industry understanding of the attack surface, interconnected assets, and unsecured interfaces. Sandia National Laboratories Cybersecurity for Electric Vehicle Charging Infrastructure. Cyberattacks targeting EVs vehicle charging is complex and can involve critical infrastructure in transportation, power, manufacturing, medical services, and agriculture. Protecting these areas of the economy is complicated and difficult. Experts propose implementing cybersecurity standards for EVs charging infrastructure to reduce the hacking risk to critical networks. They've also proposed EVs driver authentication mechanisms to strengthen security. Reliance on imported battery materials endangers the U.S. EVs industry. America relies on imported materials to build batteries that power its electric vehicles. China, a fierce economic competitor with the U.S., and dominates the global electric vehicle supply chain and many of these battery materials. That gives China an upper hand in the race to reap the benefits of electric cars, such as cost savings for drivers and better air quality in the cities because of reduced carbon emissions. That is why China is the leading electric vehicle manufacturer in the world. While the U.S. can develop a domestic battery material supply chain, it will take years before it can satisfy local demand. For example, the U.S. needs to expand its battery material production tenfold to meet the expected demand by 2030. But that isn't easy to achieve, given the complex mining permitting process. Focus on large electric SUVs, a threat to widespread EVs adoption. Large electric SUVs pose another challenge, causing vulnerability by affecting the economy and slowing EVs adoption. The bigger the electric car, the larger the battery required to power it and the higher the cost of materials and production. Raw material requirements from foreign suppliers also affect the electric vehicle economy with slow or non-existent material delivery, causing production delays. The war in Ukraine and the pandemic has shown that disrupted semiconductors, oil, natural gas, and coal supply chains in the world in turn create problems with other materials. If most all the vehicles in the United States were electric, there would be widespread disruption throughout the U.S. economy. Production delays affect vehicle sales and delivery, and, depending how dependent the U.S. is on an electric car economy, the supply chain effect needs to be analyzed further for safety reasons. EVs batteries mostly comprise lithium, cobalt, and nickel. Unlike what goes into most traditional cars, these materials are much rarer. Shortages of these materials have even caused some automakers to pause production or shift priority to more profitable car models at the expense of low-income consumers. Competition for materials worldwide will intensify as the focus turns to building large electric trucks, SUVs, and cars. This will drive up the manufacturing cost, resulting in higher car prices. Another consequence is that electric vehicles may remain expensive for a long time, making them inaccessible to low-income drivers. That would delay the purpose of widespread adoption of EVs and undermine efforts to combat climate change. Electric vehicle travel distance and charging speed issues. Most electric vehicles can only travel about 100 to 400 miles on a single charge, which is a problem on the open road and highway travel between cities. Charging time and availability is also an issue, with it taking 40 to 50 hours with a level 1 charge to an 80% in just 20 minutes to 1 hour with direct current fast charging. Not every place you go has direct current fast charging and is far from it for years to come. Cost associated with what type of electric vehicle one can afford is a big factor in vehicle selection. Then the maintenance technologies of which type of charger you can afford also affect the decision-making process of choosing the correct electric vehicle for your family or business. These factors limit the ability of some to use electric vehicles. Hybrid vehicles are often a much better solution for many today until the technology catches up with the reality of all electric vehicles. Hybrid vehicles. Just like all electric vehicles, hybrid vehicles have their pros and cons. Hybrid vehicles get higher mileage, which translates into cheaper cost per mile, and they are usually cheaper to buy than electric cars. Hybrid vehicles also have lower maintenance costs and are more eco-friendly, but they also have a downside. Disadvantages of hybrid vehicles are that even though cheaper than some electric vehicles, can still be expensive to buy. They often have less power than traditional or electric vehicles and have some of the same battery issues. But for the next 10 years, hybrid vehicles will be a better choice for many than electric vehicles. Why electric cars are still worth it. With everything covered here, it might seem like electric cars are much more trouble than they're worth. Nothing could be farther from the truth. In reality, Tesla, GM, Ford, and other automakers can't keep up with the strong demand for their electric vehicles. They're expanding their factories to produce more cars and have customers waiting many months for deliveries. Electric vehicles are fast and fun to drive. It's like some driver you know wants to get behind the wheel of an electric vehicle to at least try one. Drivers aren't just crazy about electric cars. They're drawn by the benefits. Because they don't burn fossil fuels, EVs are eco-friendly. As a result, EVs are seen as a solution to the climate change problem. Transportation accounts for nearly a third of U.S. greenhouse gas emissions. Ultimately, shifting to EVs can significantly reduce the country's emissions footprint. With the proper manufacturing and energy production adjustments, slowing climate change and reducing air pollution. Electric vehicle tax credits. The federal government is backing the EV's transition primarily on climate change grounds. Apart from funding the building of EV's charging location, the government also offers tax credits toward electric vehicle purchases. The target is to have EVs making up half of all new vehicle sales in the U.S. by 2030. The U.S. has rolled out different federal and state governments' tax credits for its citizens toward the purchase of electric vehicles, but some programs come with stipulations that could slow rather than speed up EVs adoption. EVs maintenance costs. Another reason drivers are interested in electric cars is low maintenance costs. You can save thousands of dollars in fuel expenses over the lifespan of an electric car. Because fluctuating oil prices no longer influence your driving expenses, owning an EVs may allow you to gain more control over your budget. EVs have lower maintenance service requirements than conventional cars. As a result, you can save on car repair costs. Electric cars have a longer lifespan than their gas-powered counterparts because of less moving parts. As a result, you can drive for more years before you need to replace your car. One caveat to this is the electric vehicle's long-term battery replacement costs. Most battery replacements occur under warranty. Some electric vehicles have battery coverage for 175,000 miles or 10 years. The federal minimum warranty is 8 years or 100,000 miles. If you buy a used electric vehicle, make sure you look into the cost of full battery replacement if it is out of warranty. Key takeaways. The US stands to reap many benefits from EVs, but the transition also poses various short and long-term risks to the economy. A major challenge is the many types of vulnerabilities to the power grid, with heightened risk of cyberattacks, domestic terror attacks, and extreme weather could cripple transport, shut down the electric grid, paralyzing the US economy. With massive investment into upgrading the US power grid, however, besides the conversion to an all-electric vehicle economy, many of these challenges could go away over time. Thanks for watching.